Hi friends, in this video we will understand what is functional programming and how our Java supports functional programming. Okay, so in this video we will learn what is functional programming, benefits of functional programming, and how Java supports functional programming. So using functional interfaces, lambda expressions, method references, and stream API. Okay, we will understand each and everything very clearly. Okay, let's get started. What is functional programming? So if you look at the definition of the functional programming, so it is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. So if you understand this definition clearly, then we are done with understanding functional programming. So understanding this definition is crucial. It is a simple sentence only, but there is a lot of depth in this definition. So we'll carefully analyze this definition. Okay, so it is basically the evaluation of mathematical functions. You know, right? Mathematical functions we learnt in our school days, college days, right? So how the mathematical functions we evaluate manually? The same way, if a programming language evaluates its computations are nothing but executing the logics like iterations that may be right, equals to comparisons, additions, subtractions, arithmetic operations, or performing some kind of logic. So if it computes certain kind of logic in the form of evaluation of mathematical functions, then that is a functional programming. So programming using the mathematical functions like mathematical functions is nothing but functional programming. So as we know, mathematical functions doesn't know changing the state and mutations and all those things, right? It doesn't know anything. It will just take the expression. I'll tell you how. Let's say if we open one document, let's say like this. So here, you know, right, this is a mathematical function, right? F of x comma y equals to x plus y plus 2. So how we evaluate this? Let's say x value equals to, if you say x value equals to 2, y value equals to 3, then how we evaluate? F of 2 comma 3 equals to 2 plus, we'll substitute, right, x with 2, y with 3, and constant equals to 7. This is how we evaluate mathematical functions, right? So if you take this one, is this mathematical function, does it know changing the state, changing some external things, or doing some other things? This function is completely relying on these values only, right? X and y only. It is not doing anything other than doing some operation on these two variables only, right? So that's how functions work, right? Same way, if a programming language also works, if it has to concentrate on only the input variables and it should not do any other thing like changing the object state, some external object state, or doing some printing something to the console, or connecting to the database, these kind of things, if it is not doing, it is only operating on the inputs, then that is a pure function. So in functional programming also, we have the programming language also has to do the same way. So that is how it should work. So if a programming language adopts this way of evaluation, then that is a functional programming. So I will tell you here clearly. If you see this, it is a function, right? So in functional programming also, we deal with functions. Let's say functions. So if you look at this function, it is completely reliable on these two variables, right? That means it is a pure function. In programming language, in functional programming, we deal with pure functions. It is recommended to create pure functions. What is pure function? This pure function, it will give same output for the same inputs without changing external, simply we can say without any side effects. That means if x equals to 1, if x equals to 1, y is equals to 2, then 1 plus 2 3, 3 plus 2 5. So always for x equals to 1, y is equals to 2, always the output will be 5 only, and also without any side effects. That means there will be no side effects. Side effects is nothing but we are concentrating some other things rather than operating on these two variables. That means connecting to the database, printing something to the console, or changing some variables outside of its scope. So those kind of things are side effects. So without any side effects, if a function gives the same output for the same inputs, then that kind of functions we call it as pure functions. So in functional programming we deal with pure functions. It is recommended to create pure functions always. So what is the advantage of creating pure functions? We will see. Okay, next. Okay, this is fine, we are good, right? Now we'll take one example in Java. Okay, yes. So let's create one function. Here there is no concept called function in Java, right? So always we call them as methods. So in every programming language we have a block of code, then we may call it as function, we may call it as some block of code. In Java especially we call it as method, right? Method is nothing but a function, some block of code within the flower braces, whatever we are executing, that is a function basically. But in Java we call it as method, right? So let's create one function that is nothing but method. Let's say public static int, let's say sum. Okay, it will do some sum, int a comma int b, return a plus b. So this is a function. Basically in Java it is a method, but normally in functional programming terms we call it as a function. Okay, what this function is doing, it is taking two variables a comma b and returning sum of these two variables, right? So this is a pure function. Why I am saying pure function is, it is just operating on these two variables, it is not performing any other things. Like for example, here am I connecting to some database? No. Am I connecting to some file IO, like am I reading some files, or am I writing to some files? Am I connecting to the file systems? No. For example, even if I add sysout here, it is not a pure function, because printing something is not the job of this function. It has to operate on these two. And also, you know, this is nothing but writing. It won't produce, this function won't produce the same output for the same inputs. You may ask, okay, I am passing 1 comma 2, always I am getting 1 plus 2 3 only, right? For always a equals to 1, b equals to 2, the value will be 3 only, right? You may ask like this, right? But I will say, hey, every time you are doing, it is giving the output, but what it is doing, it is also printing the output to the console. That means the state of the console is being changed always. First time the console will have only one hello one time, but the second time it will have hello 2 times. That means the state of the console is something that is external to this function, right? So we are literally changing the external state through this function. This is not recommended in pure function, right? So this is not a pure function. After adding sysout, it will become impure function. So it is recommended to deal with pure functions in functional programming. Okay, so now we understood what is pure function. Now let's take one employee class, for example. Okay, so we understood pure function. I hope you understood pure function. What is pure function? Let's say employee class. So is this employee class is having multiple methods, right? If you look at this, we have multiple getters and setters. Anyway, we have some methods. Now if you take one method, getter method, will it always gives the same value? Yes. If an object is created, any number of times if you call this, you will get the same value. We are good. So this is a pure function, right? But it will become pure function only if the value doesn't change. If this value changes, again it will become impure function. So we have to make sure that this is always final in that case, right, then only it will become pure function, right? Yes. Now if you see this, setter method, what I am doing here, I am changing the state of this object, but okay, I am changing the state of this object, but if you see this id, this is actually external to this method, right? So this is id is external to this method, right? We are actually mutating, that means we are actually changing the variable here to this method. Is this a pure function? No, it is impure function, right? So in functional programming, it is recommended to create pure functions. So how can you create it as a pure function? What I would do is, I'll make it as, whenever I change it, I have to return a new object rather than changing the variable. So for example, I will make it like this: employee sysout, sorry, not sysout, return new employee id comma whatever the existing name is there, existing name, I am just taking that. Using this changed content, I am creating a new object. Similarly here also I can do that, because set name is also not pure function, so I can do like this also, this dot id and the name. Here I can return employee, right? So if you look at this, these two always give the new objects rather than changing the existing objects. This is fine, right? Whenever I try to change the content of this object, it will always return different new object with the changed content. This is expected behavior, predictable, and this is a pure function. So for the same input, I always get the same output, right? So literally what we are doing here, we are making this employee immutable, right? So if you deal with, so that's why in functional programming, immutability is also one key principle. Okay, try to understand here. With immutability, we are able to create pure functions, right? So this is what important. So immutability is the next one we need to understand. Okay, so pure function, in order to support pure function, we need immutability also. Immutability also, right? So this is the second principle. The first principle is having pure function, and the second principle is immutability. Now, okay, this is fine. Now if you look at the mathematical functions, did you see this? We also compose the functions, functional composition. What does it mean? Let's say I will do like this also: f of g of x, right? Like this also we do, right? Let's say f of x equals to x plus 1. Okay, f of g of x equals to let's say we call it as g of x equals to x plus 3. F of g of x equals to, if I define h of x, then how we will calculate this one? Again, if g of x we will substitute, right? G of x we will substitute in place of x, and then we will calculate, right? This is functional compositions. Do you remember in your student life, in school days or college days, do you remember these kind of functions we wrote? This is called composition of the functions, combining two or more functions to create a new function. Right? The same way, since we are following the mathematical functions in functional programming also should support a function taking other function as the argument. Okay, so even the functional programming should support taking function as an argument. So this is very, very important in functional programming. So that means passing functions as variables to other functions. Is it possible in Java until till Java 7? No, right? Because if you look at this, are we able to pass methods? Because here functions are nothing but methods, right? Are we able to pass methods as arguments to the other methods? No, right? Not possible, right? Yes, not possible, because we pass primitives and objects only as arguments, not methods, right? So then how Java will support functional programming then? How could Java support functional programming if it cannot passes method has an argument into another function, another method, right? This is a challenge definitely Java might have faced. So what Java did for that? What is the alternative it thought, and how it would make it? That's what we have to understand now. Okay, can we understand? Yes, be ready. So let's take one example here. I would like to explain this with some beautiful example. Let's write that here. Let's take one example that I have a list. Okay, I have a list of let's say numbers. Okay, and I want to create a new list by doubling each number in the list. Okay, that means this is list 1. I want to create a new list 2 by doubling each number in the list 1. Okay, let's say I have this requirement. Okay, can we do it? Yes. What I will do, first I will create a list. Okay, list of integer list 1 equals to list of 1 comma 2 comma 3 comma 4. Okay, I have a list. So generally what we do, we'll take a first of all we will create one list here, list 2 new array list, right? Normally we do like this, right? After doing that, what we'll do, we'll take some for loop for each. Let's say what we will do, int I list 1. What we will do next, in the list 2 we will add, right? We will add by doubling it, right? Into 2. That's it, right? We do like this only, right? Yes. If we print it, we can see the output. Normally this is how we do, right? Nice, very nice. Now today you wrote like this. I will get another requirement that use the same logic for tripling these values. Let's say I am mapping with doubling the number, but next step please triple this one, each number in the list. What you will do? Do you write for loop again? That is not a good idea, right? So what we will do, I will create a method for this. Okay, let's do that. Public, let's we can also do like this, source refactor extract method. What we can do, something called map we can give. Okay, right? Okay, Eclipse did it for us. I'm doing it here, I'm pasting it here. Okay, so it is taking list as a parameter, and okay, it did it. Okay, fine, we are good, right? Okay, this is better, right? We are good, right? Okay, now see, this works for only doubling the number, not for tripling the number, right? We can reuse this method, of course, for the for loop to create the list and adding the numbers to the list, and you can return. You can reuse for this purpose. for iteration purpose and adding to the list, but we cannot reuse this, right, because it is working for only doubling the number. Let's say I got another requirement. What is the requirement I got is I want to create a new list 3 by tripling each number in the list 1. So what would you do? This should be dynamic, right? Okay, well, I will do one thing. Instead of hard coding the logic here, I will create one more method here, private static. Here also I don't do manual work. Here I will utilize my Eclipse refactor extract method. This one I will name it as double number. Okay, right, done. So it is here. I'll just paste here. Okay, wow. So we were able to refactor it. So double number, whatever the change dot whatever, if I change the logic here, that should be fine. No need to change this one. So this is something called separation of concerns, right? Okay, modularity. Okay, right. So now for example, I want to pass triple number now in place of double number. What can I do it? What can I do? Because in order to reuse this, because I don't want to repeat this logic for tripling the number, to map after tripling the numbers, I want to reuse this logic. So what can I do? I have to do something which I can pass something here, maybe triple something, double or triple like this, something here. That something, use this something I have to use here, so that dynamically if I pass double number, it has to double. If I pass triple number, it has to triple. So I have to do something here, right? That means I have to literally pass this logic here. Otherwise this method is nothing but function. If I am able to pass this function as an argument to this function, this method, then it will become possible, right? So how we can do it? That's what Java people thought, and they came up with one approach. First, initially, okay, forget about Java 8. If I want to reuse this, what you would do, I will create one interface, because interface we can change the implementations, right? So that's why I would go for interface. What I will do normally, I will create a function, one interface called function, and I would create one method called let's say this will return something int, because here also I am returning int, right? And it will name something called apply. Any name should be fine, and it will also take some int. Okay, this way I can define one interface with one method, and this I can create some implementation for this with this one method, and that implementation class I can pass over here, right? That is one way. Can we do that? And also this implementation, we'll do one thing. For now, here I'll create the implementation here itself. Okay, function f is equals to new function, and anonymous class only I am creating here. Instead of creating a new class file, here I am creating an anonymous class. Okay, add unimplemented methods. Int I, actually this is only taking only one. Oh yeah, it is taking only one, right? Okay, that's fine. So that one we have to double it, right? So this is double function. Okay, double function. Okay, I'm doing like this, double function. So it will make it as double always, times 2. Okay, it will make it as twice, right? Nice, right? So this double function, what I will do is here I will pass the function. Okay, function f, right? Interface. So I can pass its implementation, right? Here what I can do, I can pass the implementation. Yes, here I can pass. It has two methods now. Other one, double function I can pass like this, right? Now this double function, from this function, what is the method we have? Apply we have, right? F dot apply. What is the yes, apply. So what it will do, it will automatically, implementation is nothing but what? Implementation method is doubling, right? Automatically it will double and it will transform, right? So this is nice. This is one way, right? I can reuse now. Okay, somewhere yeah, it is declaration, right? We need to end it with semicolon. this is good, right? And I'm able to double. So tomorrow if I want to reuse this, what I can do, I have to pass the implementation for this with one method. That should be fine, right? So what I can do, for example, I want to triple. What I have to do, again I have to repeat this. This time it will be triple function, right? It should be 3 times, right? Okay, if I want to triple, see, I'm accomplishing my requirement with this approach initially. I think this will work fine, right? Now I will print list 3 also. Okay, yes, 3 6 9 12. So congratulations, now we refactored the code in such a way that we can reuse this method also. We can reuse this for logic also. Literally we abstracted, using this map function, we abstracted the iteration logic from this list also. We are not bothered how we are how we are transforming this list with this implementation, right? So if you look at this, we are not bothered how it is transforming, but it is transforming, right? So congratulations to this. We have to congratulate ourselves with this approach. Yes, from until Java 8 I would do like this. I'm happy with my code because I'm able to reuse the logic, right? Now this is fine. But the only worrying thing is this code, because I have to repeat this new function. I have to repeat this method implementation. Here also the same. I have to repeat this new function, and I have to repeat this overriding and these many lines, right? This is something cumbersome, right? Because we need to tell, for example, my final goal is to provide this particular implementation. My final goal is to provide this particular behavior, but here, in order to provide this particular line, we have to write this much code. So this way of coding until Java 7 is imperative. In imperative coding, we need to concentrate on how to do and what to do. So what to do is nothing but I into 2. How to do is nothing but creating the new function like this and overriding the method. So this is called imperative way of programming, But in Java 8 solved this problem with some special kind of syntax. What is the syntax? Come on, let's go. I will remove this whole. Here if you see, actually where we have to concentrate, this method only, right? Finally this method is important, right? What it is taking, what it is returning, right? So what we can do is here, what it is taking, int I, and a special kind of syntax, that is arrow mark, and here what we are returning, I into 2, right? I into, let's say for triple function I need 3. So this is, see, we are not getting any compile time errors, so this is valid in Java 8. So literally we are providing a special kind of syntax in place of this anonymous class with single method. Remember, this will work with only single method. Let's say if it has 2 methods, we are overriding 2 methods in this function, then it doesn't know this implementation is for which method. So that's why this expression, this syntax works for interfaces with one method only. Okay, remember. Now we are good, right? Even this is also optional. Data type is also optional. We can happily remove this. It will automatically identify it because it has only one method, right? And even for one, if there is a one parameter, even this parenthesis is also optional. We can remove it. It become more concise, right? Wow! And by seeing this code for the first time, when I started learning Java 8 functional features, especially this kind of expression, after seeing this, I felt very happy because easily I can escape from this kind of coding, right? It saved my time also, and it is more readable. What we are doing here, it is taking one argument, it is returning, multiplying by 3, it is returning the value. So behavior we are providing directly, right? So very happy to see this. So this will also work. Let's execute and see. Yes, it is working fine. So this Java 8 called this expression has lambda expression. So lambda expression is nothing but it represents an anonymous class with one method. It represents an anonymous class with one method only. This is nothing but lambda expression. Simple. Yes, we'll talk about lambda expressions in deep. Currently we will understand. So okay, this way we can do it, right? So anyway, now if you see this, so we are able to reuse this, right? Correct. So in functional programming, function should have the ability to take another function as an argument. So now are we able to do that? Yes, we are taking one function is taking other function has an argument. So we are successful in implementing functional programming, and also Java is also supporting functional programming because it is able to pass the one function into another function, right? So and also it is providing one shortcut way for that. It is looking like a behavior because we are not worrying about this one because this is saying how to do, but here we are concentrating on only what to do. So this way of coding we call it as declarative. We declare, that's it, what to do, that's it. Here we will declare, we will also do how to do also, right? This is called imperative programming. So this is called declarative programming. Okay, functional programming is a declarative. Okay, so this is what we need to understand. So here one more thing, these functions which are taking another functions has arguments are nothing but higher order functions. I repeat, the functions which are taking other functions has arguments are called higher order functions. So using these higher order functions, what is the benefit we are getting? We are able to abstract the logic from the arguments, right? And also using this is called functional composition also because we are combining two functions to produce some output. So this is also called functional composition. Okay, using functional composition we are able to get the benefit, that is abstraction, right? Yeah, so this is another feature we need to understand, that functional composition that is achieved using higher order functions. So higher order functions is also one key principle in functional programming. Okay, so what we learned so far? Pure function, immutability, and higher order functions. Okay, pure functions, immutability, and higher order functions. And one more interesting thing is that if you look at this, does functions know for loops, while loops in mathematics? No, right? Okay, if it has to perform some iterative logic, what it will do in mathematics? How we will do, right? Mathematics doesn't know about for loops and while loops, right? If we follow the principles of mathematical functions, then mathematical functions do not know about for loop, while loops, right? They know how, if they want to perform some iterative logic, how do they do in mathematics? How do we do? How do we do? Recursion, right? Recursion. So in mathematics we do recursion for iterative logics, but in programming we have for loops, while loops. Recursion is recommended over for loops and while loops in functional programming, but in Java, if you do recursion, in some cases we may get stack overflow exception, right? We need to carefully evaluate. There are some techniques also while recursion to avoid stack overflow. We can follow those techniques to implement recursion, but it is not functional programming in Java. It is not pure functional programming. It is not forcing you to do to use recursion, but it is up to you to use recursion or not. But generally, from pure functional programming languages recommend recursion. Okay. After this, one important principle in functional programming, that referential transparency. I think this is the first time we are hearing this, right? Referential transparency. What does it mean? In referential transparency, if an expression can be replaced by its output without impacting the program, then that is referential transparency. Let's see with example. Let's say I have an expression, I have a function. Let's say this is my function, double number int. Okay, let's say I'm using here, let's say here I'm adding double number, I want to pass one number 2. Okay, int y is equals to double number 2. Okay, and one more time, int z is equals to 5, int x equals to y plus z. Now double number always gives what? 4 only, right? If I for testing purpose, I want to instead of executing this function, I want to replace it's with value. Okay, let's say I want to replace it with 4. First of all, I will just run this one. I will just x I will print, the result I will print. So 9 we are getting, right, totally. Now if I replace this with its value, that means I'm literally replacing this function with its output. What's the output for this? 4 only, right? So is it impacting the program? No, right? So these kind of expressions or functions exhibit referential transparency. So this is called referential transparency. This is one feature, one principle or one property of functional programming. So this also we have to follow while creating functions. We have to make sure that okay, always we should be able to replace functions with its values so that it won't impact the entire program. If you create like that, we will gain benefits. Those benefits also we will understand. Okay, so referential transparency is also one more property we need to understand. So these are the 5 principles. These are nothing but we derived these principles from the mathematical functions only, because mathematical functions exhibit referential transparency. They are pure functions, they won't change the state, and they also, one function can take another function as an argument. That is higher order functions, and mathematic functions follow recursion, that is recursion. So these are all the principles are coming from the mathematical functions only. So this is what the depth we need to understand what is functional programming. So the definition itself is saying, right, it is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data, right? And also in functional programming, functions are first class citizens. First class citizens is one term when we use, meaning they can be assigned to variables, passed as arguments to other functions, and returned as values also from the other functions. So in functional programming, those lambda expressions we are able to assign to the variables or function types or interface types, and also we can pass those lambda expressions as arguments, and also we can return those lambda expressions from the functions. So lambda expressions are nothing but here they are actually functions. We can say they are representing anonymous class. Of course they are first class citizens in Java 8, right? So functions are first class citizens in functional programming normally. So in Java is also supporting that, right? So this is what functional programming. Now we will understand the definition of functional programming in depth. Okay, so it is deterministic. That means mathematical functions, right? It is always, it says it is a functional programming paradigm. It is a programming paradigm that treats computation has an evaluation of mathematical expression. So we need to compare with the mathematical functions always. Okay, so it always produces the same output for the same input, right? So this is deterministic. So by seeing the function itself, we can say okay, for this particular input it will produce this kind of output. It won't change. For the same input it will not produce different outputs. So that is deterministic, right? Similarly, functions in programming, especially pure functions, exhibit this deterministic behavior, right? So they are in functional programming, the functions are matching with the mathematical functions. They have to match. Then only we call it as functional programming. Next, pure functions. Pure. So mathematical functions don't have side effects, and they don't modify external state. There is no such concept in mathematics, right? Similarly, pure functions in functional programming avoid side effects and only rely on their input parameters to produce output. So this is very important in functional programming. Referential transparency. In mathematics, expressions can be easily replaced by their values without changing the result of computation, right? So for the same input, always same output. So we can easily replace the expressions with its values output, right? This property is known as referential transparency, is also desirable in functional programming, where it ensures that replacing a function call with its return value won't affect the program's behavior. This is what important. Okay, next, compositionality. This one we saw, right? So one function taking the other function has an argument, so we are combining the functions. So mathematical functions can be composed to create new functions, right? Similarly, functions in functional programming can be composed, allowing for the creation of complex functionality from simpler building blocks. So we can combine multiple functions to build complex logic also. So what is the advantage of splitting the functionality into multiple functions is modularity. They will easily scale. We have some benefits. We can easily maintain, and we can easily test also, right? Next, no mutability. In functional programming, always preferable is immutable. So mathematical functions operate on immutable values. Similarly, functional programming discourages mutable state and encourages the use of immutable data structures. Remember, whenever you are working in multi-threading environment, where we create immutable objects, so immutable objects plays a very vital role. So that is very, very important. So even when we work with functional programming, definitely we have to build immutable objects. And also variables, also we declare final variables to show our intention that these variables, once we assign values to these special instance variables, we won't be changing those values again and again. So immutability is the key principle in functional programming. So by adhering to these principles, treating functions as mathematical functions, functional programming languages aim to create code that is easier to reason about. Easier to reason about means nothing but easy to understand and predict, okay, what is happening, and test and maintain. So due to these reasons, we are adopting functional programming. Okay, this approach promotes modularity, clarity, reliability in software development. Okay, so this is what we need to understand the definition in depth. Okay, normally when we say, if someone asks what is functional programming, we give the definition, and also we need to give what are the principles involved in functional programming. Those we already discussed. Again, we will see in points. Pure functions. So the key principle, one of the key principles is pure functions. Functions that always produce the same output for the same input and have no side effects. They rely only on their arguments and do not modify any external state. So this is the behavior of mathematical function, right? So in functional programming, we create such kind of functions also. Those we call it as pure functions. Next, immutable data. So as we already discussed, data structures also once created cannot be modified in functional programming. That is how we need to create. Instead, new data structures are created with modifications as necessary. This makes it easier to reason about the behavior of the program. Higher order functions we discussed, right? Functions that take other functions as arguments or return functions as results. These allows for the composition of functions and enables powerful abstractions. We saw that example, right? Yes. Recursion. Functional programming languages often use recursion instead of looping structure constructs like for or while loops. But in Java, be careful while implementing recursion logic, because we may get stack overflow exception, and we have some techniques to avoid that stack overflow exception. We can see that later point of time. And referential transparency, as we already discussed, the ability to replace a function call with its resulting value without changing the program's behavior. This property facilitates reasoning about and optimizing code. How it optimizes code also we can see. You know, in JavaScript or in some other languages, we have memoizing. Memoizing is a concept where we store the results of a function for a certain input in cache for complex calculations. Okay, whenever we want to calculate for the same input, we don't calculate again. Instead of calculating it again, we will get that result from the cache, so that it will improve the performance. This is called optimizing. So if a function exhibits referential transparency, that means same output for the same input, and that output can be replaced with the expression. That means the expression can be replaced with the value. Then easily we can memoize it, right? That means we can store the result in some cache for that particular input. Whenever we face the same input, we can instead of calculating it again, we can fetch the result from the cache. So that is a very big advantage of referential transparency. Okay, so these are the 5 principles we can easily we can say about functional programming. Okay, functional programming means this one. Okay, yes, congratulations. Okay, now we will understand how Java supports functional programming. So now we know what are the principles of functional programming, right? So what is the definition of functional programming? So what are the principles of functional programming? Now how Java supports functional programming from Java 8, we will understand. Okay, what are the features it released in Java 8 so that it will support functional programming and we are able to do functional programming, right? So so what are the features? What it has provided is, first thing is lambda expressions. It provided lambda expressions. So using the lambda expressions, we are able to directly define the behavior, right? Instead of implementing the interface with anonymous class or some classes, we are able to directly define the behavior, right, at the function. So this is a completely a change in the programming paradigm in Java 8 especially. And also it provided method references. So these method references are also a shorthand syntax for lambda expressions. Sometimes we feel very convenient. Okay, already we are feeling convenient with lambda expressions. Sometimes we feel more convenient using method references. Whenever we have to execute, whenever we need to call some method in lambda expressions body, then we use method references. We will see that practically, what is the syntax for it also. And you know, lambda expressions, method references, these two, and also it provided functional interfaces. One feature, functional interfaces. See, functional interface is nothing but a function with only one abstract method, and it can have any number of default methods and static methods. Okay, but it should have only one abstract method, because we are assigning the lambda expressions to interfaces, right? So the lambda expression is nothing but behavior, right? That behavior is nothing but one method, right? That is one method behavior that should be assigned to functional interface. That means functional interface, if it has only one method, then only we can assign that behavior to that functional interface, right? So that's why only one abstract method is allowed in functional interface. We will see that in practical. And after all these three, Java provided Stream API. When we say Stream API, it provided some built-in support for collections, to process collections. In regularly we process collections, right, in Java, because in real-time applications we get data from database, then we store that data in collections, right? Maybe probably mostly in list or set or map. Then we will process those records in the list, right? So what are the common problems we face while processing collections? What are the common things we do with collections? Using all those things in mind, Java, what they did is they provided Stream API with some methods, with some higher order functions. Using those functions, those are nothing but some operations we do. Using those, we can easily perform so many common operations on collections. So it is very essential to learn Stream API when we learn Java 8, especially functional programming. Okay, so we need to, in Java 8 we need to understand how to define lambda expressions, how to write, and how to use method references. We need to know how we can use method references in place of lambda expressions. And also we need to understand what is a functional interface and how it is helping us. And Java provided many functional interfaces. We need to know them, because if we know them, then we are able to utilize them. If we don't know them, we need to create our own functional interfaces. So what are the functional interfaces Java provided? We have to be aware of those. And also we need to know how to use Stream API. So these are the features, these are the things provided by Java as part of Java 8 to support functional programming. Okay, these things, with these 4 we have to keep in our mind. Okay, yes. Now let's start. What is lambda expression? We will understand. Okay, we already saw one example with one lambda expression, but actually we will see in depth. Okay, what is lambda expression, how to define it. Okay, a lambda expression is a concise way to represent an anonymous class, right? This is what we saw, right? Yes, lambda expressions provide a way to pass functionality as an argument to a method, or to create a simple instance of a functional interface, right? We are passing the functionality as an argument, right? That's what we saw, right? And also it's nothing but an instance of a functional interface, right? Yes. Why we are saying functional interface? Because whenever we use lambda expression, the interface should have only one abstract method. So the interface which is having only one abstract method is nothing but functional interface. Okay, anyway, we'll understand this. So syntax of a lambda expression, it is essential to understand syntax of a lambda expression. Okay, first of all, it will have parameters, a comma separated list of parameters, same like how we have comma separated parameters as method arguments. The same way we have comma separated list of parameters enclosed in parentheses. If the lambda expression does not take any parameters, then empty parentheses are used. Okay, that also we will see. If it is not taking any arguments, okay, we have methods which do not take arguments also, right? So for those methods we will see empty parentheses we have to use. Okay, next, arrow operator. So this arrow operator or arrow mark separates the parameter list from the body of the lambda expression. The same way, if you take a one method will have parameter list, argument list, and method body will have, right? So the same way here also we have those two, the method argument, the parameters list, and the body, method body, those to be separated by something, right? That is here arrow operator. Okay, body. So the body is nothing but the method body. How, like in method body whatever we write the logic, the same logic we put in the lambda expressions body. So the body of the lambda expressions, which can be a single expression or a block of code. So we saw, right, without block, single expression also we wrote, right? So without the single expression, without the single expression means we have to write, if we need to write block of code, certain steps, let's say like 10 statements or 5 statements, if we want to write, we should put them in a block. That means in the curly braces we should put them. Okay, if the body is a single expression, it is simply return. There we have not used return statement. That means if it is a single expression, implicitly compiler will add return statement. So if it has multiple, if it is a block of code, that means if you put in the curly braces, we have to use the return statement explicitly. Okay, so we will see this in practical. Okay, syntax of a lambda expression. Okay, so I'm just removing all this. Okay, we'll use this anyway. So let's say this function, I will take this function as an example. Okay, function is taking one argument and returning something, right? So how do we define it? Function f equals to I, arrow operator, some operation I into 2. So this is how we can define the lambda expression. Let's say it is not taking anything. Let's say it is taking one more. Let's say int j, it is taking one more. If it takes 2 arguments, then we have to define I comma j. It is up to you. It can be a comma b also. It doesn't mean that I should be same as I, not like that. It can be a comma b also. Let's say I will make it as a, I will make it as b. Okay, whenever we have more than one argument, okay, whenever we have more than one argument, then we have to enclose them with parentheses. Here parentheses are mandatory. If you have more than one argument or one parameter, parentheses are mandatory. Okay, so this is how we have to do. Okay, and we may not have, sometimes we may not have anything, and we may return some value, right? So in this case what we can do is we can remove this one. So this is how we need to define. Okay, let's say I want to print something, because I should not return anything, right? Hello. Okay, so this is how we can do what it is saying here. Okay, it is saying something should return, right? So I have to return something here. Let's say some value, let's say int only, right? So 2. Okay, it always return 2. Okay, so this is how we need to give empty parentheses. So if you think about different types of methods, some methods may take arguments, they may not take arguments. Some methods may not return value, some methods may return value. So different types will have different way of defining lambda expressions. For example, if I don't return anything like this, see, if you see this, this method is not taking any argument, but it is not, and also it is not returning anything. So in this case, how do you define? Empty parenthesis, and you have to do something here. What you have to do? Let's say I want to print something. I can print it. Okay, like this. I can do it. Okay. And if for example, this is okay, fine. If I want to return something, you must return something. If you want to take arguments, you have to take arguments. So this is how you have to do. Let's say if I have multiple blocks, let's say I want to execute multiple statements inside this block. Okay, then what I have to do? I have to enclose them like this. Okay, and even for single also, even for single statements also, I can enclose in the block. I can have multiple statements anyway, like this. We have to enclose them in the parenthesis if you have multiple statements like this. Okay, and if I remove this, will it work? It won't work. What it is doing? It is working, right? Still it is working, right? Yes. So even without curly braces, it will work. But if you observe, are these two statements belonging to this function, or only this is belonging to this function? Maybe these two is it is coming out of the block, right? So maybe this is out of this, maybe, right? Let's print and see. See, only two hellos are coming, right? So that means these two are getting printed, not this one. So this is belonging to the function actually. Okay, if you enclose it, it will become part of the lambda expression. Okay, yeah. So anyway, so if you have to return something like this, int, then we can return something, return 1, something like this. So in this case, we have to put return statement. Okay, but if it is in the single line with single expression, return is not required, right? So this is what we need to understand here. Okay, so this is about lambda expressions, defining in different ways. Okay, now this is okay. This is about lambda expression, right? Now we will see about something called method reference, because Java is also providing method reference in Java 8. So how to use method reference, we will understand. Okay, a method reference in Java is a shorthand syntax for invoking a method on specific object or class. Okay, so if you want to invoke a method on a specific object or class, then we can use method reference shorthand syntax. It's very simple than lambda expressions. I feel this is very shorter than lambda expression, I can say. It provides a way to refer to a method without explicitly writing a lambda expression to call that method. We will see this practically. They provide a more concise and readable alternative to lambda expressions, especially when the method being referenced is a static method, or an instance method of an existing object, or even a constructor also. If you want to create a new object as part of the lambda expression, then easily we can use the method reference. I will show you practically. Syntax forms. What are the syntax forms? Static method, if you want to refer static method, then you have to use class name : method name. This is how we need to refer. If it is an instance method, we need to give like this: instance : method name. If it is a constructor reference, class name : new, then it will create a new object with the constructor reference like this. So these are the three different types of syntaxes we have. Okay, for static method reference, instance method reference, and constructor reference. So method reference, how to use, we will see one demo. Let's say I have a function, and it won't take anything, it will print something. Okay, so what I can do is function f. It won't take anything, but I want to print it something, right? If you see this, I'm actually calling println method on out object, right? On system.out object, system is a class. In that we have a static variable, which is a reference variable, and reference variable, using this reference variable, we are actually calling the println method, right? Can we convert this can we convert this into method reference? Yes, we can do it. Before that, what I will do is I will just define to print something. Okay, so this is how we define the lambda expression, right? This one I will convert to method expression. F2 equals to, simply, what is the syntax? Instance. What is the instance here? System dot out, right? Instance variable, colon colon println. That's it. Now this will work. See, is it reducing the size of lambda expression or not? Yes, right, it is doing, right? So this is what we need to understand. Okay, yes, let's okay, f2 dot apply, I will pass something, right? Let's say Rakesh. Okay, it will print, right? Yes, it is printing. That's it. I'm calling the apply method. So this is a shorthand syntax we need to understand. So now see, some static reference also we will understand. Okay, what I will do is, for that I will create a static method. Okay, public static, let's say it won't return anything, it will just print it. Okay, print. Okay, print, it will print whatever we are passing. Inside I am using sysout to print the name. So what I can do is, here this f2, this is instance, right? This is instance variable, right? Now using the static way also I can do. Here the print method is there, that is inside this is a static method, and also it is inside main class, right? What I can do is, here also simply I can do main class name colon colon print. It will also work. If you say f3 dot apply, it will print. So this is static way, static method reference. This is instance method reference, and we have one more reference called constructor reference to create a new object. If you want to create a new object, in that case also you can use the constructor reference. For example, what we can do here is, for constructor reference, I need a class. Yes, what we will do is, here let's say this will always return employee. Okay, but what it will take some arguments. Let's take one employee class here, ID and name. Okay, int ID, string name. It will take these two and it will create an employee object for me, let's say. Okay, just for demonstration purpose, let's remove all this. What we can do is, function, normally using lambda expression, what we do, it will take ID and name, right? So I comma or a comma b, right? New employee a comma b. Okay, it is correct only, right? So f dot apply, what I have to pass, some ID 1 Rakesh, right? I have to do something like this, right? So what I have to do now, employee is equals to, now you can print the employee and see. So this is how we can create an instance using lambda expression. Yes, 1 and Rakesh, right? This is okay, right? Now again, here also I can use constructor reference. It's very easy. It is again easy than lambda expression. What I have to do, same class name colon colon new. That's it, over. This is f2, let's say f2 dot apply, f2 dot apply. Now you can also see the same way it will work. It is working, right? See which one you feel comfortable, that one you can use. Nothing wrong in using lambda expressions. If you are confused or if you are not comfortable using method references, you can always do with lambda. And if you are habituated to use, if you love method reference, then you can use method reference in these cases like this. Okay, that is up to you what you want to use in your projects. Okay. Both will be supported from Java 8 onwards. Okay. Now, okay, we understood how to write lambda expressions, and now we understood how to write method references, right? So we are good. Now, one thing we have to understand is, here we are defining interface with only one abstract method, right? But okay, if I define one more abstract method, will it work? Let's say here apply to. This is okay here, it is not giving any errors. But if you see here, this is giving compile time error. The target type of this expression must be a functional interface, right? Here also the same, I think, right? The target type of this expression must be a functional interface, right? Oh, here we need to understand what does it mean. So we are providing, literally we are providing the behavior, right? There is a one method implementation only we are providing. But if you have two implementations like this, it doesn't know which method to consider, right? So that's why it is giving the compile time error. So that's why the interfaces, these interfaces, when we use the interfaces along with the lambda expressions or method references, the interface should have only one abstract method. Such type of interfaces, Java named them as functional interfaces. Functional interfaces. So in functional programming, we use these interfaces. We assign lambda expressions especially. But these are also normal interfaces only, but with only one abstract method, then only lambda expressions will work, right? So we have to remove this. We are good. Let's say, okay, I created one interface somewhere. I have a very big code base, and I have started using this function in so many places, like this, in other classes. Suddenly tomorrow a new developer came, and okay, when I am a developer, I know that I'm going to use this interface for functional programming purpose. But tomorrow other developer comes, he doesn't know about this interface. He may come and he may accidentally add one interface, one method here, right? That is possible, right, when we work as a team. So in order to avoid this accidental adding of these methods, because it should have only one abstract method, right? In order to avoid accidentally adding more abstract methods, Java provided one annotation. If you add that annotation, it will restrict it to one abstract method only. It won't allow to add one more. Here itself it will give compile time error. What is the annotation is? Functional interface. So if you add this one, see here itself we are getting the compile time error, right? Function is not a functional interface. So that's why we have to remove this. So this is the safest way. Adding, this is not mandatory, but it is recommended to use functional interface annotation. Whenever our intention is to create functional interface, it is recommended to use @functional interface annotation. So now we know what is functional interface, right? It will have only one abstract method, but any number of default and static methods. But abstract method, it should contain only one. So this is what you need to remember. Okay. Now let's understand what is functional interface. A functional interface in Java is an interface that contains exactly one abstract method, but it can contain any number of default and static methods. Okay. Functional interfaces are a key concept in Java support for functional programming. So without functional interfaces, it is difficult for Java. That means we cannot write always in anonymous classes, right? With one interface, and we need to add, and also without functional interfaces, that means functional interfaces without functional interfaces, it is difficult to write lambda expressions, right? Lambda expressions are nothing but the behavior for only one method. That means the interface should have only one method. So that's why functional interfaces are a key concept in Java support for functional programming and are used extensively with lambda expressions and method references. So these three combinations always, functional interfaces with lambda expressions, functional interfaces with method references, will be seeing in functional programming. Whenever you go to a project and if you see a code base, if you start going through the code, whenever you see functional interfaces and lambda expressions, okay, then you can understand, okay, these people used functional programming a lot. Okay, good. like that you can think. Okay, at the rate functional interface annotation, you know, right? Functional and interfaces are annotated with at the rate functional interface annotation, but which is optional but recommended. Okay, this annotation ensures that interface meets the requirements of a functional interface and helps prevent accidental addition of more abstract methods. That's what we understood, right? Right. Okay, now we understood, right? Functional interface also. Benefits of functional programming. Before jumping into benefits of functional programming, I want to explain one more example using functional programming. Now we know lambda expressions, method references, functional interfaces, right? Before jumping into it, I would like to introduce one more thing. I would like to explain one more thing, that is here. Okay, one example I want to explain. Before that, I want to let you know one more thing, that is, you know, here you are writing your own interface, your functional interface, right? But this is not at all required in Java yet, because we have to say thanks to Java that these kind of interfaces already provided by Java for us, so we can happily use them. So what are those functional interfaces provided by Java? Is, let's go into one Word document, and here we will see functional interfaces provided by Java. What are the functional interfaces provided by Java? The main important functional interfaces are, first one, we start with function. There is a functional interface which is already provided by Java. We will see where it is. Okay, then also we have predicate. This is one functional interface, and also we have consumer and also we have producer. We call it as supplier, not producer, sorry. And this function will method will have one argument, predicate also will take one argument, consumer won't take any, supplier won't take any argument, but it will return something. Okay, for function which is taking only one argument, right? To take two arguments also we have one more functional interface, that is by function. Predicate also will take only one argument. If you want to pass two arguments, we have one more functional interface called by predicate. Consumer will consume, it can consume only, it consumes, consumer will consume only one argument, and for two arguments we have by consumer. By means two, right? Normally, right? By consumer. We don't have by supplier because supplier is not taking anything, right? So anyway, these are the important. Okay, we have many like operators, binary operators, some kind of operators also, but anyway, those are the extensions of this. Anyway, these are the main important, we can just put in our mind. Okay, function, predicate, consumer, supplier, by function, by predicate, by consumer. These are very easy to remember, also not that difficult. We can easily see this function. If you go function, I will show you function what it is containing. I will just put it in the class so that we can import and see it. See, we can see, right? Function java.util.function package. So here we have, I want to remove this my functional interface anyway, so I want to use this. I will import this. Now it is a generic type because it will, I will open and show you. So see, it is starting from 1.8, okay, and it is a functional interface annotation is there. So if you see, apply method is there. They have provided one method called apply. So this is a one abstract method, and it has other methods also. Default method is there, default method, static methods are also there. Okay. So generics will allow you us to deal with different data types, right? So thanks to Java for providing such kind of interfaces for us. Otherwise we have to create our own functional interfaces. It is again effort, right? So T means nothing but what it is, what it takes, right? What it takes, and R is nothing but what it returns, right? So we have to pass them. Let's say in my case here I want to replace it with this function, then I can replace it, right? What it is taking, it is actually taking a comma b, right? For employee class, a is nothing but, so it is 2, it is taking 2, we cannot replace, right? We can replace it with by function. Okay, so by function also we will see. Okay, by function, if you see, By function also has one method. It will take two arguments. The data types are t and u, and data type is r. Okay, this is also one functional interface, right? It takes two arguments, and here we can declare, right, what it is taking to. First one is integer, second one is string. And what is the return type? Return type is the object, right? Employee. If you put like this, it should work, right? What is the error it is giving? Incorrect number of arguments of type function t comma r. Okay, it is a function, sorry, by function we have to take, right? Yes, perfect. See, I have deleted my own function. Now I am able to successfully use the functional interface which is provided by Java, right? Here also I can replace. This is F2 by function, right? It will work, right? Yes, it is working. So we have different functional interfaces provided by Java. So you understood function and by function. And similarly, what we have, predicate we have, right? Predicate is for Boolean. I will show you predicate. Predicate, if you go, predicate, if you open and see, we have a test method, and it takes one argument, any argument, and it will return Boolean. If you want to check conditions like whether it is true or false, then you have to use this predicate functional interface, okay? Whether that is true or false, like that. Let's say I can choose, for example, let's say it will take some string, and predicate p is equals to let's say s colon s dot equals, whether it is equal to hello or not. So I can define one expression like this, okay? Predicate we can use like this, right? Boolean expression. So what will happen in this case? P dot test hello. If we write, then let's print and see p dot test, right? If it is hello, then only it will return true, right? So that way also we can use. So true. So this way we can define the lambda expressions for predicate. Similarly, we have for consumer, by consumer. So you can explore all this, very simple. It accepts something, it won't return anything. So you can use this. And consumer, by consumer also you can check. By consumer will take two arguments, right? Remove this. By consumer will take two arguments. It will have method, accept method having two arguments, okay? So you can explore all this, okay? Very simple. By supplier, won't take anything, but it will return something, okay? That also you can see. Supplier, supplier is there. It supplies something, it returns something, but it won't accept anything. See, it is not accepting anything, but it returns something, okay? We can use this one also. So anyway, different types of functional interfaces it provided for us. We can happily use them instead of creating our own functional interfaces. But our requirement doesn't satisfy. I mean, if none of the functional interfaces provided by Java are not satisfying our requirement, then we can create our own functional interface, okay? This is what we need to understand. Yeah. So with this knowledge, let's create a sample requirement. I would like make, I mean, we have to think in functional programming, right? So that's why I would like to provide one example, okay, just to make you start thinking in functional programming, okay, functional way, okay, functional style, okay. Let's remove all this. The requirement is I have a person class, okay, I have a person class, okay, and this person class has name and age. It has some constructor, and it has some getters and setters and all those things, okay, fine. Now my requirement is to make person class is there, right? In the person class, I will pass the person object. I want to uppercase the name, and I want to increment the age by 1. These two operations I want to perform on the person class. In functional way, how will you do it? So how will you do it? I would normally for incrementing, yeah, and also this person class, okay, good. And also one more thing is that it should be scalable. That means for uppercasing the name, I would like to create one method, and incrementing the age, I would like to create other method. Why? Because sometimes I may decrement also, so that I can combine different methods to get the required output. Okay, so what normally we do, we create methods, right? Instead of creating methods, we have to create lambda expressions. So for incrementing the age, what we have to do is and also after incrementing the age, it has to return a new object, right? Yes. So what I will do is, first of all, I will take static. It has to return person, right? Person. But it has to return person. Okay, we will return anyway. We would like to take what kind of arguments it will take. It will take here, if you see person, what arguments it will take? Name and age, right? Okay, but what is the input we will give? We will give the input as person only, right? Okay, the input will be person. Okay, that means only one argument. So function we can use, right? One argument only, right? So function we can use. So function will take one argument as person. What you want to return? I want to return person only. So here, this is for uppercasing, right? Uppercase. Okay, and what is the logic I want to build? So it will take person as input. Let's say person, or it's up to you. Person, new person I want to create. So person dot uppercase, right? Get name to uppercase. It's a new object. I want to create new object here. Why? Because what is the reason? Immutable manner we have to do, right? We should not change the existing object. Uppercase, and can you tell me? Age, right? What is the age? We don't know, right? Person dot get age. Whatever the person we are passing, right, as an input. Person dot get age. So this is one expression. What we can do is, we can put this into the next line to understand better. Okay, this is one expression. See, in functional programming, this is how we need to think. And this is uppercase, right? And next function, again same, person comma person, age, right? Increment age, right? Increment age. Same, right? We'll move to the next line. Person, arrow, new person, person dot. This one should not be altered, right? What is happening here? Sorry, here spelling mistake is there, right? Person dot get age, right? Comma. What next? First parameter is not age, right? First parameter is name. So name, age has to be incremented, right? Person dot get age, increment by 1. That's it. Now I have 2. These two I can commonly mix, because this is called composition. So these two I will utilize to get my requirement. I have to uppercase and increment, right? These two I have to combine. So for combination, again I can create one more function. This function also will take person, and it will give the person as the output. So this is the operation I will do. Okay, some operation. So here, first of all, what I have to do, uppercase I have to perform, right? So what I will do is, uppercase I will perform. First I will pass the person dot colon uppercase, right? Uppercase dot apply, right? Person. After applying, then see here, no need to call apply method. Just we need to just to combine the functions. Okay, what we have to do is uppercase then and then simple uppercase and then what you want to do, what I want to combine increment age, right? Just increment age you can give like this. Then after combining these two like this, then you can start applying and you can pass the apply person. So why I am creating this example is to demonstrate how we can combine the functions. So first I am uppercasing, I am getting a new object with uppercase name with the same age, and after getting the new object, that object is getting passed for the increment age. So increment age, how we are doing the same name we are taking and incrementing the age, and then we are applying. We are calling the apply method with that person. So this is how we need to create combine. Now definitely this operation dot apply. So some person I will create 1 comma name, right? Rakesh comma age, let's say age 24. That's it. So now we can print and see. Let's say if it is person p equals 2, okay, then I can print and see. So name became Rakesh and age became 25. So this is how you need to think in functional way. Okay, no creating normal methods like this. We have to split into see, for uppercasing and increment age we can put all this logic in single method, but what is the putting this in different methods is I will tell you now itself. Now I got another requirement to decrement age, uppercase and decrement, or what you will do. So for decrement again I will do one more operation. That means I will define one more variable like this, and here this time this is decrement age, right? This is -1. That's it. Here what I will do, this is operation 1. Let's say I will create one more operation. This is operation 2. Same combination here, instead of uppercase same I have to repeat, and this time it is decrement age, right? Decrement age. That's it. If I do operation 2 dot apply, then I will get decremented 23, right? So this is how we need to think in functional terms, functional style. Definitely we have benefits. What are all the benefits we will see now. So what are the benefits of functional programming? First thing what we saw, conciseness, right? So functional programming reduces boilerplate code, just to be declaration way, right? Leading to shorter, more expressive programs. Okay. Immutability, we saw, right? Immutability data structures prevent unexpected changes, improving code predictability and concurrency. So this is normally immutability advantage. Whenever we use immutability, so these are the advantages we get, right? Concurrency and predictability. Pure functions, right? Mathematical functions are pure functions. So if you use pure functions with no side effects, right, it enhances code reliability, testing and parallelism also. So since we are not modifying the external state, so we can directly use these functions in parallelism, right, in the multi-threading. So we won't get any race conditions or any concurrency issues. Higher order functions, just we saw, right? Functions has first class citizens. First class citizens are nothing but what? They can be assigned to variables, passed as arguments to the functions, and also returned from the functions. Enable powerful abstractions and composition, right? Abstractions we saw, right? We abstracted the for loop logic from the list, right? And composition, we are able to combine multiple functions, right? Composition. So this is what higher order functions. So once we use higher order functions, these are the benefits we will get. Declarative style, this is what I like. Focus on what to do rather than how to do, right? Leading to clearer and more maintainable code, right? Parallelism, functional programming encourages stateless operations, right? We are not modifying the data, right, there. So facilitating parallel and distributed processing. Simpler debugging, so we reduced mutable state. You know, in functional programming there are situations we may need to modify the objects, but immutable manner we will do it. But there are some situations we may need to create impure functions also. But since we have reducing the mutable state and side effects, make programs easier to debug and reason about. This is what, if we create immutable objects, it is easy for debugging also. Mathematical foundation, see, Functional program is grounded in mathematical principles, right? That's what we have been discussing, right? So it's basically those are the mathematical functions. How mathematical functions are evaluated, the same way we need to evaluate our program code computation, right? So that's why, so we like this, if we evaluate, then definitely it will give a rigorous framework for software development. Scalability, see, because of these features, definitely the code will become scalable, and because of the modularity and reusability, the whenever the code base will become bigger, it is easy to scale. It's not that difficult. Easily we can scale the everything, whatever methods and the functionality, everything we can scale very easily because of modularity and reusability. So these are all the benefits of functional programming. So next, we need to understand about Stream API. That's what we discussed, right? What we discussed, what are the how Java is providing support for functional programming means we discussed these four, right? Lambda expressions, method references, functional interfaces, Stream API, right? So these three we have learned. We saw some examples. What is Stream API? Yes, Stream API we have to master, because Java provided inbuilt methods to process the collections efficiently in functional style. Okay, so Stream API we will understand and practice in another video. Okay, thanks for watching. Please subscribe for more videos.